Hello folks, today I am drawing the ray diagram for Simple Microscope. So I'll be dealing with the techniques to draw it. So in a Simple Microscope, what we have is it is a simple magnifying glass in which the image is formed at the same side as the object. The image virtual, magnified, and so on. So what I'll first do is I'll first decide where to form the image, where to have the eyes and draw the line likewise. So to have magnified image, I must leave some space here. So let me leave some 6-7 line space or more than that, and draw a line here. So draw the principal axis here. So you decide how large the image that you want and leave space likewise. Today I am not using scale. It's because I want to try my hand. Want to see whether I can draw presentable straight lines or not. So first you draw the principal axis, which is 2 cm from this side and 2 cm from this side as well. So 2 cm from the left and right side. Then you from 1 cm from here you will fix the position of the eyes. So let us say this is E here, and 1 cm from here you will fix the position of the image, the final image, which is virtual and large. So let's draw that image. So I'm starting from the image because I'm not going through the straight method. I'm not guessing where the image will form. I'm right in the very beginning. I'm forming this image. So this is the virtual image. Now then what I do is, so from here to here I draw a straight line. So I'll try to make it as straight as possible. So I draw straight line from here to here. So it should be somewhat like this, somewhat like this, almost straight. So this is the straight line. It is forming a right angled triangle. Now I will choose the size of the object. Let us say I want to make the object size like this. So about 5 times less than this. So if I draw like this, so let us say I want to be the object size like this. Object size. So at this position I will have the lens here. I'll have the lens, convex lens here. So this is the optical axis of the convex lens dotted here. So let me draw the lens like this. This is the lens and this is the lens. So this is the convex lens. So I want to make the object of this size. So from here what I do is, so from here what I have to do is, now let's connect this and this. So if I do this thing, if I connect these things, so let me draw it like this. So it's almost being connected like this. Yeah. So it's not perfectly straight, but I would consider almost straight. So now I'll connect this line, draw a line parallel to this thing. So from here parallel to this thing, and this will be the position of the object. So this thing will be the position of the object. So I am drawing backward here. So slightly confusing also. So now the light ray goes from here, object here goes from here. Since it goes parallelly to the principal axis, it will go through the focus after diffraction. So this is the focus point. It goes straight through the optical axis. Let me say this is the axis, the point O here. So this ray goes like this, and all other things are virtual. So now I place the eyes over here, So this is the position of the eye. From the eye it feels that the rays are coming from certain other point. So these things are virtual. So that's why I have to make them dotted. So I frequently try this. I draw all the things and I dot these virtual things. And this is a very good way to punish those people who do not use pencils. I often do that in class, and they often shy. They often say bad words about me, or at least inside their hearts. But I feel very happy about that. Very happy. So now this is the focus here. As we have said, the object should be within the focus. So this is the focus here. The same thing here. So the focus should be somewhere here. Focus here, object here. So let's say it is A, B. It becomes A prime and B prime. And this is the angle beta, which is the visual angle after using the device. Now when we compare compare things in the simple microscope, we have to compare in such a way that the object also is in the same distance. The object also is in the same distance. So what we need to do that is, let's draw that case also. Let us place the object here and see what is the visual angle. So that requires a small space here, slightly below that. We don't need much space. So let me draw the principal axis here also. So it is the case we are dealing with when we place just the object and the eye. And the eye will be in this position. So this is the position of the eye here. Once again, the eye will be in this position. So this is the position here. And when I place the object here, when it goes here, it will be just like this. So this is the object here. It will be somewhat like this, like this. So this is X, Y. And from here, the light ray goes like this. It is almost touching here, so slightly my hand curved. Yeah, so this is alpha. So light ray goes from here. So this is the visual angle with the object in the same distance, and this is the visual angle with the image at the same distance. And the distance is, this whole distance is V equal to minus D minimum. It is the distance of the least distance of distant vision. This is of the near point. So this is how we draw the ray diagram for a simple microscope. So that's how we compare